Hello. Calculating the intrinsic value of an investment can be very tough, and there are all sorts of models that can help us with evaluating a stock and a company. One of the very well known models that is very widely used is the discounted free cash flow model, which actually relies on the free cash flow that the company is making to create projections about what the future free cash flow of the company will be and how much a person would be willing to pay for that cash flow today. Now, there are many videos, of course, that you can find online and a lot of courses and that you can watch to understand how this model works. But I wanted to make a very simple video that actually explains that in layman's terms, and it doesn't go too deeply into accounting. I just wanted to help you understand what this concept is about without you having to be an accountant, because I'm not an accountant myself. However, it's very important to understand how this works because it's vital when you are trying to understand what is the current value of a future investment. Because when you're buying a stock in a company today, what is its worth today? The worth of that is, for the most part, what the company is going to be producing for the next years. This may be 5 years or 10 years. And so, in order to help you better understand what this concept is about, first of all, don't pay too much attention on this. I'm going to be explaining it as we go. This is just the whole video in one spot. So, let's picture here that we have an investment. In this situation, we bought something that, let's say it's a company that produces $10 a year. That's a very bad company in terms of free cash flow, but picture that for a second. So we know we have a company that produces $10 in every year, and we're gonna be operating this company for the next 5 years. Let's picture that the company is actually going down in year 5, at the end of year 5. The reason doesn't really matter, it just goes down. So we now have an investment that we know it's going to be making $10 a year. So if we wanted to buy this investment today, what is the cost? What is the cost that we would be willing to pay for that investment today in order to get it and get this yield for the next 5 years? Now, obviously it has to be less than 50, right? Because every year the company is making 10 and 10 and 10 and 10 and 10 here, right? So it's gonna give us $10 at the end of year 5. So are we willing to pay $50? Of course not. I mean, where are we going to be paying $50 for something that's going to give us $50 back in the next 5 years? I mean, there's inflation in between. We're effectively losing money if we do that. Are we willing to pay $40? Well, that sounds more interesting because now we are actually making $10 at the end of year 5. But are we really making $10? Because there is also inflation that is eating up our money, right, in between. So $10 today are not the same as $10 in year 5. They're actually less because money today is worth more than money in 5 or 10 years. That's because of inflation, right? And so what we are doing when we are evaluating these investments, we are calculating what the present value of all of these future cash flows is going to be. And in order to have a margin of safety, we're using a discounted rate, a discount rate. So what is this discount rate about? Now, the discount rate could be basically inflation. So if inflation is 3%, we want to calculate how much money we're going to be making if we account for that inflation, right? Because inflation would be eating up our money every year. However, we don't just want to discount 3% because we want to make some money on top of that, right? So ideally, we want at least 10% because typically a normal S&P 500 ETF makes about 10% a year. And so when we are investing in a company, we actually want a better yield than that. And so a good idea is to use a discount rate of maybe 12% or 15% when we're talking about a company and you want to evaluate it using a discounted, using a DCF model, discounted cash flow model. Now, how does that work now? So picture that we have $10 today. This is the free cash flow that we have currently. Now, in year one, we have $10. And if we have an interest rate of 10%, what does that mean? It means that in the second, at the end of the next year, we're going to be having 10% plus of our current cash flow. So this means that we're getting $11, 10 multiplied by 1.1, right? So we made 10% on our initial money. So if we know that we're gonna be making $10, because we do know that in year one we're not making $11, we know that we're making $10, right? So here we made 11, we started with 10 and we made 11. But if we made 10, what would be our starting value? This is what we're examining. What would be our present value? So if our future value is $10, what would be our present value? So this is what we're trying to find with this model. And the way to do it is by using the discount formula pretty much. And we can, this is mathematics really, but we can use this one to quickly evaluate what the present value of our current future value is going to be. And PV stands for present value. It's basically the amount of money that is represented today as we are talking. And future value is the future value, the value that's projected to be sometime into the future. And R is the discount rate in our case, or it could be the interest rate. 10% is what we're using here in this example. And N is the number of years that we are doing the projection in the future. So this could be year 3 or year 4 or year 1. Now, if we have $10 today, right, which is our present value based on the interest formula here, at the end of year 1 we will have this, which is the interest formula, is what we calculated earlier over here. So it's $10 multiplied by 101, but by 1.1 gives us $11. So we will have $11 in 1 year if we apply 10% interest. That's very intuitive for most people. But now, since we know that we are having $10 in year 1, right, instead of 11, that would be. This means that if we discount that for today, we would have this, and this is this formula. So future value here is 10, is this value over here that we know we're getting in year 1. Then 10 multiplied by this expression here, and R is 0.1 because it's 10%. It's the discount rate, 0.1, 10%. And then it's raised to the power of n being the year number. So we're taking a look at year 1. So if we do this calculation, we're getting that the present value of our future value of $10 in year 1, today it would be discounted at $9.09. And that's because the interest, the discount rate, is eating up our money as the years progress. And so this is basically the discount rate is the exact inverse of the interest rate. That's what it is. And $10 in year 1 are 9.1, as you see here today. And now if we do the same calculation, the same formula for year 2, year 3, year 4, year 5, as you see here, we're getting 8.26 for year 2. Remember, that's because 10% is applied for 2 years now. So it's accumulating, it's compounding, inversely compounding. It's not the same as interest, but it's the same concept. We'll have to do the inverse calculation. Year 3, 7.51. And I haven't updated this one this year, it's my bad. So year 4 is actually 6.83 here, and year 5 is 6.20 over here. Is what you see here. These are updated normally. Now, we know that we're getting this kind of money on year 1, 2, 3, 4, 5. And so now we can use all of these numbers to calculate how much money we will be making in 5 years' time if we discount this with a 10% rate for today. And why are we using a discount rate, we said? Because we need to be making some money, right? And so this means that if we actually add these numbers together, over here you see 9.1, 8.26, 7.51 plus 6.83 plus 620 is giving us $37.9. And that basically means that we are willing to pay $37.9 at most in order to make sure that we're getting a 10% gain on our money every year. So if we discount that gain, that total $50 gain in 5 years that we're going to be getting, we need to be paying at most 37.9 to make sure that we're making some profit of 10% a year, right? This is what this whole concept of the discounted free cash flow model means. We want to evaluate, we want to use mathematics in order to determine how much we are going to be willing to pay today in order to make $50 in this case in 5 years. Again, because we want to account for inflation, we want to account for gains because we need to be making some money. And again, if we use 3% here, which is like the inflation rate, for example, or 2%, 2.5, we would be discovering how much our money would be worth today if we adjust them for inflation in 5 years' time. So hopefully that helps you understand what we are looking into when we're using a discounted free cash flow model. And I wanted to make this video again just to show you a very, very simple mechanism to understand how this works, because I understand that this can be a little bit annoying and a little bit confusing to get the gist of. It is a little bit confusing, but if you think about it logically, it's a simple concept. We're basically trying to understand how much we're willing to pay in order to be able to make this gain every year. That's what it is. And just because money loses value year over year, we want to be adjusting for that loss every year and discount that loss back to our present value in order to know how much we're willing to pay today in order to make this amount, this gain, in 5 years. And so hopefully that helps you understand how this works. And you can now see why I really like using free cash flow in my analysis on when I'm talking about specific stocks. It's very, very important, very, 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 very crucial to understand why free cash flow is so vital for companies and your investing. You need to be making sure that you're making money with your investing. And what's another better way than actually looking into the money that the company is making, free cash flow that the company is making, which is operating free cash flow minus capital expenditures, is as low as you can get pretty much, or for the most part. Now, this can be much more complicated for computing discount rates, for example, can be a very, very complicated model, even just computing that. But as a simple investor that we are not really hedge funds, we can just use a discount rate of 10%, 12%, and just play with it and see how much we're willing to pay. It's more like an art, sort of, which uses mathematics, though it's a combination of science and art, really. So hopefully that video was helpful for you. If that did help you and you did understand how free cash flow works with that video, let me know, and please leave a like and subscribe to the channel. And I'd love to see you in our Discord channel as well. You can find the link in the description box below. Thank you for watching this, and I'll see you in the next video. Bye bye.